Hello, how are you doing? In our class today, we're going to be learning physics, and in physics, we're learning our elasticity part 1A. Now, in this elasticity, we're going to be dealing with some topics, and besides, already know my name is Ambassador. Now, coming to this outline, we have some topics to deal with. The first one, we're going to learn about the definition of elasticity. We're going to learn about the picture representation of elasticity of a material, the things we use in elasticity and their formulas. We're going to learn about Hooke's law. Likewise, we're going to know what we call work done. After that, we're going to have some exam pass questions in this topic. Now, before we start, what do you understand by the word elastic or elasticity? When the word elasticity, what comes to your mind? It means the ability of a material to be stretched. That means when the material can be stretched, it can be stretched when stretched and also can regain back its shape. That's all about what we refer to as an elastic material. So any material capable of stretching, and when you stretch it, it can regain back its shape, is referred to as elastic material. And that's how we derive our elasticity. And not something, it's not all material that can be stretched. I with me, it's not all material that can be stretched. And there's always a limit to every material that can be stretched. Firstly, I said it's not all material that can be stretched, and two, there's always a limit to all material that can be stretched. So we want to delve into all this understanding and all these things, stretch, not stretch, many other things. So let's delve into the work. Coming to the work, we have introduction and definition of elasticity. Introduction and definition of elasticity. So what is elasticity? Before you have to understand that material that can be distorted or by changing that shape. I with me, any material that can be distorted or by changing that shape is always referred to as elastic material. As far you can distort the shape of the material and they can change the shape of the material, that material is typically elastic material. And I said something here, any material that's able to regain its shape after destruction. Now, you behind the word destruction, what does destruction mean? It means to deform a thing or to change a thing by applying either a force or you're applying a load. That means to change a thing or to deform a thing by applying either a force or a load to that thing. For instance, let's talk about rubber. For instance, you look at a rubber is in a circular form. When I try to put um, a ball here, what do you observe? We found out that the rubber will change its shape. Why? Because the ball is already applying a force, or let me say, the ball is already applying a load. So whenever you find a material, when they are being distorted by a body or a force or a load, you refer to that material as elastic material. And besides, when I try to distort the body and we find that it changes its size, and I try to move back the ball, we see that it's going to regain back its size. So those material are generally referred to as an elastic material. So that's that on that. So a typical example of what we are talking about of elastic material is just your rubber and your spring. A typical example of elastic material is just simply your rubber and your spring. So they are the examples of elastic material that we have. So let's move on to the definition of what is elasticity. Definition of what is elasticity. What is elasticity? Simply by saying this is the ability of elastic material. You can see the word elastic material to regain its shape after deformation. I said at that time, deformation here means when you try to apply a load or when you try to apply a force. So that means whenever an elastic material has the ability to regain back its shape whenever a force is applied on it. For instance, look at this example here. Look at the example carefully. You see, we have two force here. That means somebody is pulling the rubber here, and that person is pulling the rubber here. And this is the elastic material. Now, the ability for the material after being deformed by the application of the two forces that are here, going back to its position or going back to its former shape is called elasticity. It's called elasticity. It's called elasticity. So that's the meaning of elasticity. So that's that. Then let's move on to another thing we call Hooke's law. What is Hooke's law? We heard the word Hooke's law. And this was discovered by a man called Robert Hooke. Now, Robert Hooke is also found in biology. He was one that contributed to what we refer to as the discovery of cell. He was the first man that examined cell. So he also propounded some laws in cell, and also he's also propounded some laws in physics, especially your elasticity. Now, a man called Robert Hooke proposed a law that we call Hooke's law. Now, what does Hooke actually talk about elasticity? He says that, pay attention carefully. He says that if an elastic material has not exceeded elastic limit or stretch. Now, please be careful with the word elastic limit. I told you that some limit at which an elastic material can get to. So, elastic limit refers to probably the material has not been overstretched. When it's overstretched, it will perform this law. Are you with me? So let's see what the law says. So, it said if an elastic material has not exceeded elastic limit or stretch, the extension of the material is directly proportional to the applied force or load. Okay, let me explain to you what Hooke is saying here. This is Robert Hooke, as you can see here, a man called Robert Hooke. He's an English scientist, to be fat, an English scientist. Now, what is he trying to say about what we refer to as elastic material? Looking at this carefully, this is spring. We have a spring here. A spring. Now, this spring is at its normal position. Are you seeing that? So, when you try to apply a load, looking at this is a load here. When you apply a load, what happened? We found that the spring is going to be distorted. That means it's going to be way down or sagging down. This is because a load is applied to the spring. And the load will determine the amount of extension the spring is going to reach. Now, considering this is our load, which is called the mass, and the mass is being pulled down a little bit by force. You can see that as it's pulling down, there is a change in what we call extension, which is your x. A change in what we call extension, which is the what? Your x. Okay, another example here. Look at it. When I try to increase the mass, we find that there's a bigger change again in the extension. So that means Hooke is trying to figure that as there is more force or more load applied to the spring, which is your elastic material, there's higher extension. That means change in length of the material. So that means if my force should increase, I'm going to have a change in extension. If my force should decrease, I'm going to have a change in extension coming down. That's what Hooke is talking about here. Now let's see the mathematical expression of what Hooke is saying. He said if an elastic material has not exceeded its elastic limit, he said the force applied to the elastic material is directly proportional. It means the force applied to F is directly proportional to your extension. So when they say direct proportional, it means you have that F direct proportional to E. I see that. And this our proportionality sign, which is here, is going to produce the constant K. Now the constant K here, please pay attention here. The constant K here is called force constant. You can call it force constant, or you can call it stiffness constant. It's either called force constant or it's called your stiffness constant. That is the value or the name of the K here. You call it force constant or you call it stiffness constant. So this is the force formula or the expression of Robert Hooke law. Now, coming down to how we can get our force constant. We need to know how to get our force constant. If you look at it, we have that F equals to your KE. And you know that this is your force constant. What are we supposed to do? We need to divide both sides by your extension. So you know that your constant will not turn to F all over your E because we are dealing with what? Your force constant. And besides, this is the formula we use to derive for our force constant. I think that. Looking at this, here is called your force, and here is called your extension. And don't forget, I told you the other time, extension means change in length. And what is the unit for force? Unit for force is in Newton, and extension is also in meter because we are talking about the length of the material, change in length. So therefore, we have the unit for the force constant. Please pay attention to this, very important. This is your K as Newton all over meter. So this is the unit for the force constant. Now that we've already understood what we refer to as our Hooke's law, and we see some formula we can use to get our Hooke's law. That is what we are going to know in the Hooke's law. So let's apply some questions from our exam to see how we can apply this Hooke's law in our exam question. Okay, so now we are going to solve some questions on it. For our question here, we have the drill one. Drill one. In our drill one, we are given that a spring, look at this carefully, a spring is stretched 40 millimeter. So that means you are given the extension of the spring is stretched 40 millimeter. By a force of 15 newton. You are given the force as 15 newton.